Hello. It is onwards to day 18 of Advent of Code. Day 18 and a short description today, only 1.5 pages. What do we have? Lavaduct Lagoon. Thanks to your efforts, the machine parts factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They've asked you to take a look at the dig plan, your puzzle input. For example, there's this kind of thing, which is R6 and then parentheses and this kind of hash code. The digger starts in a 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left or right, clearing full 1 meter cubes as they go. The directions are given a scene from above. So if up were north, then right would be east and so on. Each trench is also listed with the color that the edge of the trench should be painted as a hexadecimal color code. Okay, so RGB colors. When viewed from above, the above example dig plan would result in the following loop of trench, having been dug out from the otherwise ground level terrain. Okay, there's a loop that follows this walk instructions. At this point, the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. Okay, so it's still the interior. Now the lagoon can contain a much more respectable 62 cubic meters of lava. While the interior is dug out, the edges are also painted according to the color code in the dig plan. The elves are concerned the lagoon won't be large enough. If they follow their dig plan, how many cubic meters of lava would it hold? A flood fill problem. We already did one of those. Why do we have a second flood fill problem? Oh wait, no. So this kind of tells that Eric didn't intend for that, was it like that pipe loop puzzle, day 10 or something? I bet he didn't intend that to be solved with a flood fill. So he was intending for the point in polygon test to be used on that day's problem, rather than flood filling. So now we're flood filling again. Well, that's boring. Actually, hold on. Now I know what I can do. When I was reading the solutions for day 10 puzzle, some people said that instead of flood filling, they calculated they used shoelace formula to calculate the area of that rectilinear polygon. So maybe I'll use that instead of doing the flat fill, because I already did the flat fill. So yeah. So so I read back on, like, was it day 10 or day 9, whichever the pipe loop thing was. I read the Wikipedia page to calculating the area of a polygon just based on the corner points. So I could use that. So if I calculate the corner points of this polygon like this, yeah, I could calculate the the area of this trench then just from the coordinates without needing to do a flat fill, and that would be faster. Although the trouble is actually that because of this RGB code thing, I bet I will have to implement that flat fill in part 2. There's some kind of, I think we'll be coloring all of this, and maybe it's asking for like an average color or something like that. I don't know. But so if I do this for part 1, I think I will still be implementing that flat fill for part 2. But it doesn't matter. I'll do this and then yeah, then I'll do the flat fill for part 2. So at least I get to do something different. Cool. Okay, so let's capture the puzzle inputs. So here's the puzzle input. Like this. Save 9 2023.example18 txt. Okay. And then this one 9 2023 input 18 txt. Yeah, so with the trapezoid formula, it's kind of remarkable. Like you compute the area of like these trapezoids that fall under the polygon, and then basically they end up canceling each other out to compute only the the area that lies actually within the polygon. So I think that will work well. So let's get going. So like this, and then S contains the line, so that's like 40 characters maybe, and while F gets no. Today I'm gonna use fscan F. So while fscan F from file under character length open parents hash I don't have a hex string modifier, so I'll use this one. And then character direction, and then int number char string So direction number and s is greater than 0. Oh, so actually this is greater than 2. Okay. Let's see. Printf char and direction and number. Okay, let's see how this works. Works just fine. So yeah, so I'll try to use the trapezoid formula. So the trapezoid, we start with x0, y0 in the corner. And we start going to the right. So I need to calculate the new x2 and y2 coordinates. And that depends on direction. If direction actually I need to do winding order. So char right if d equals up, then we wrote, so or not right, but let's do clockwise. So if I'm going up, I need to rotate to the right. And if I am going to the right, I need to go down. And if I am going down, return left. And otherwise return up. So then in the previous direction, previous direction equals well, probably doesn't matter what this equals. So if the new direction is clockwise from previous direction, or actually no, it does matter. So this needs to be up. We are returning to the top left, so this needs to be up. So then then I also need these direction vectors. Int dx or the if d equals to the right, return 1. If d goes to the left, return -1. Otherwise, return 0. D left. Can I fit this on one line? Then -1, otherwise 0. And then dy going down, going up. Okay. So if I'm turning clockwise, that means that x2 plus equals num times dx of dir, and y2 plus equals num times dy of dir. Else if direction, or else direction must be counterclockwise. And what does this mean? x2 plus equals num -1 times dx here, right? And y2 plus equals num -1 times dy. Okay, these multiplications are really silly. Really silly. Let me do int l, then I can do l minus l, and then also int l minus l. So then I can do here num -1. So this -1 is because if I'm doing a counterclockwise turn, I'm kind of stopping the rotation short of one character. And then I have area is 0. So the area is the average, or the like the area of that trapezoid. Signed area of the trapezoid. So area plus equals x2 minus x1 times y2. Is that right? And then x equals x2, y equals y2, brave direction equals here. That's kind of peculiar code. I have an odd feeling about this, but yeah, that's what my instincts tell me. So let's see, printf. What is the final coordinate we get to and the area? So that is x, y area. -0 area -8. Okay, let me print the coordinates. Ooh. And pause. So the first coordinate we're at is right 6. So 1. No, that's not right. 1, 2, 3, 4, 5, 6. Oh, I see. Okay. No. It has to be +1 here and minus here. 70. Yep. Okay, what do we get in the -65, so 62. And I'm now at -1. Still not quite right. So let's see. So 70. So this is 0, 0. 0, 0, 1, 2, 3, 4, 7, 0. So that's right. We're at 7, 0. And then we go 1, 2, 3, 5, 6. So we should be at 7, 6. Yeah, we're at 7, 6. And then we should go to, so that one there is 7, 6. That should be 5, 6. No, we go to 4, 6. Hmm. So right 6. 1, 2, 3, 4, 5. So right 6 we get 7. Then down 5. Then left 2. Wait, down. So this is clockwise, clockwise, clockwise. Oh, it's not. Oh, I see. It's it's not about this winding direction, but it's about the next one. So I need to do f scan f %c %d %s. In previous num, previous direction, previous number. So previous year, previous num. Yes. Oh no. Previous year here, and then previous num here. Previous year, previous num. Previous year, previous number. So it's basically this one. But then I need to manage the tail manually. And previous num equals num. Yeah, then I need to manage the last one manually, but let's see if this this even works. Seven 0 7 6 5 6. Yes, this would be 5 7. 5 7 5 6 5 7. This should have been 5 7. That should be 5 7 there, and then 7 7. Okay. Let's see. Okay, this was maybe a little bit more convoluted, but I think I should be able to make it work. So this is a clockwise direction, and this this is in counterclockwise direction. Let's see what I get. Write down. Yep, so I'm going right and the next one is going down. So I'm here 7. Seven zero, yep. Down left. I come to this corner, so that's also a clockwise rotation. And then I should get counterclockwise rotation, yes. Then I should get another counterclockwise rotation. Length 2. Why does that work in that case but not in the other? That's very remarkable. We moved 2 squares twice and the other time it's the rule that if we make 2 counterclockwise rotations in a turn, so previous was counterclockwise equals true, previous was counterclockwise equals false. Is this the rule? 7076 56 57 87. Hmm. 8 10. Really peculiar. Really peculiar. Okay, this might be something that I need to take another thing. Why? Like it feels like these winding directions are. Oh, okay. Okay, so I think I give up. I need this logic is a little bit more convoluted, but yeah. So the thing is, instead of trying to figure out what's the issue with this winding thing, I'm not sure if I should be tracking like which side of a square I'm on or what, but now I'm getting the feeling that because I do need to do the flat fill for part 2, I might as well pivot and do that instead. Although this is a kind of an interesting problem. I should probably give that a think. Seems like you need to track like which of the 4 corners of a cell you're in. And then depending if you do a counterclockwise or clockwise winding, then you kind of like either go to the far end or in the short end of that cell. It's a little bit convoluted, but okay. Yeah, I'll abandon this line because I think this is not going to be solving part 2. Very fascinating indeed. Okay, let's go back. So we get the parsing. Okay, this printing is not needed. Yeah, that's kind of curious. Okay, so now these coordinates just mean actual integer coordinates. So I'll have a map. I don't know what size my map will be. Actually, let's calculate what size my map will be. Int width equals 0, height equals 0. X plus equals delta x direction length. Y plus equals delta y direction length. Width equals max width and x. Plus 1. Height equals max height y plus 1. And width height. Seven by 10. Looks about right. How about the input? 379 by 166. Okay. 379 by 166. Okay, so I'm going to use a bitmap. Map 512 by 256 divided by 2 by 8. So what is that? That is 9 bits, 8 bits, and 3, 16, 17, minus 3, 14 bits. So that's 16 kilobytes. 16 kilobytes. Variable length array declaration. Huh, I don't like my division there. Okay, so and then I do void mark u8x, u8y. U24 index equals U24 y shifted left to the 9 bits. Ordered by x, and then map index shifted right by 3, ordered by 1 shifted left by index and 7. Okay. How do I do this nicely? If direction is left or direction is right, or now I feel like I'm gonna be doing for while num minus minus mark those can be whatever, those can be ints, x minus minus y. Okay, now I'm already getting to the packing game. Okay. Left, right, up, down. Left, right, up, down. Okay. And then I need a number of marked nodes. How large is this? How large is this? Okay, so it does fit in 16 bits. So this one is enough. And actually this index can then be oh, but it cannot. Yeah, okay. And then I am going to have struct u16 yeah, u16x u8y stack. Let's go with 512. Should be plenty. Stack stack pointer equals stack. SB++ equals node 1 1. So I think because we're doing this kind of loop, we will always have the coordinate 1 1 be inside this loop. If we start at top left and start by going right, so we will come back up at the very end. So this will always be inside, while stack pointer is not stack. If now I need to have a check for whether the map has been marked. So bool marked u16x u8y. Return that. Okay. Okay, so what is it complaining about now? Oh, expected. Okay, so if not marked SPX SPY, if SPX greater than 0, mark SPX SPY. minus. Actually, I need to copy. U16x equals SPX. U8y equals SPY. Go here. Minus minus SP. If not marked. And if x greater than 0 equals x minus 1y. Yes, and oh, actually, no, I don't need to do these checks because this is already bounded. X plus. Well, I should probably do, if not marked, x minus 1y. Yeah, that I should do because otherwise this stack is gonna grow like heck. Marked x plus 1, y minus 1, y plus 1, x plus 1, minus 1, y plus 1. Say what? Non-constant expression cannot be. How is that possible? And why there? Oh, it's because I need to do a cast. Whatever, I'll just use. No. Very peculiar. Okay, let me do fill x minus 1 y, or actually stack pointer. Let's do it like this. Yeah, you can go in global memory like this. Okay, so U16 x, u, and y. So like this. SPX equals X, SPY equals Y, plus SP. And then I can do those struct initializers. I wonder what's going on there. Oh. Okay. Okay, that needed some operating, but yeah. Field. Or was it marked? $38. Should be 62. Oh, I'm not filling. The width and height anymore. Let's do that. So width equals max width x plus 1, y equals max y non height equals max height y plus 1. And then let's do for volume height plus y for x equals 0, x more than width plus x. Marked x, y, then otherwise okay. What's going on here? Let's see. We're not filling anything. Not flat filling anything, but otherwise, yeah, otherwise it's coming out pretty nice. Okay. No, I don't need this one anymore. Oh. Oh. This needs to be like this. No. Oh, oh, what is that? What is that? Still nothing. Okay. Uh, 18A CPP. Huh. What was I screwing up? Okay, so need this one. What am I doing wrong here? What am I doing wrong here? Let's see. Zero, zero. It's looking at 0, 0. What? Is that happening immediately at start? Yes. What the heck? Stack pointer x equals 1, stack pointer y equals 1 plus sp. For sure, this should print 1, 1 as the first node it visits. Like, I cannot... 0, 0. What on earth? And huh. How peculiar. How peculiar. Now it's doing it. $62. And that's the right. So what is happening here? 62. If I change this to minus minus SP, minus minus SP here. Now it's still doing it properly. Why didn't it? How bizarre. How utterly bizarre. Okay, but anyways, now it's right, and now it's doing the fill. So that means that I can try my luck on the big input. Let's see what happens. There are a lot of cells to fill in that one. Okay, so that it loaded the whole map, and now it's oh, I should have probably added a print when it completes the contour. And I crash. Did I run out of my stack? Did I run out of my stack? Oh, I probably did, because I had, oh, no, that's, yeah, this was the wrong way to do a flat fill. Yeah, I always forget. So I did a bad flat fill. Because here, fill. Yeah, so I need to eagerly mark. So what I need to do is mark 1, 1. And then I cannot check here if not marked. We will always be marked. But instead, we will always be marked, so fill, yeah, we eagerly mark here, mark X, Y. Excess elements. Okay. Yeah, this is the way we need to do it. 62. Yeah. Printf filling. What? A type specifier is required. Oh. Here. Okay. And actually, why not? We have plenty of space. Yeah, because otherwise you end up lots of duplicate nodes in your stack. And that just kills your performance. Oh, still crashing. Still crashing. And oh, and even more crashing. Why would we crash? Well, let me add double checks that we don't blow up. So if SP if SP is more than stack plus 415. Yeah, let's do it like this. Okay, and now yeah, I mean this should end up in a closed loop. But maybe I have some. Let me add checks here. If x is 0 or y equals 0 or x equal width minus 1 or y equals height minus 1. So that shouldn't happen either, because we should have a closed contour. Yeah. Okay, so what do we get here? So x coordinate is okay. 11 by 0. What? So I don't have a closed contour. Can I see what it draws? Okay. Oh, I did. Wait, what? What the heck is going on? And this looks like a nice line, but the top left part is... Oh, are they being sneaky and this is not the top left? Yeah. Okay. Okay, I see. Maybe. Um, did I have int max? Yes. So min width equals min x, min height equals min height. Yeah. Is that what they're doing? Or do I just have a bug in my... Okay, let's see. Why minus 256? Okay. So let's say we start at 2, but that seems actually a little bit suspicious. Actually, it seems a little bit suspicious to me. And now that I actually think about it, no, that's fine. No, that's fine. Width int min int min minimum, and then okay, whatever you can be there. And then maximum. So I've now offset y by 256. Yeah, max 379422. But wait, still I get this weird shape. Oh, 422, because now the y coordinate also 379 by 422. Okay, so everything is... Let's start from my first assumptions. So here, U16Y. Index is initially 32. Actually, okay, I can't even feed it. Oh, come on. So Well, before I go and fix all of that, let me calculate. Oh, actually, no. Why can't it just double? So that's one bit more. Which still fits. It still fits. Yeah. Oh, so sneaky. I thought they were being nice and like being at the upper left corner, but nope. Okay. X and Y. Fill X and Y. Integer. Yeah, I mean those could all be integers. Like now I'm a little bit mixing unsigned and signed. Okay. Okay, that was sneaky. So let's see what this now does. Do I still have issues or? I do still have issues. What the heck? Okay, what am I doing? Oh, crap. What is going on? What is going on? Oh, now I understand. No. Everything might have been okay. Everything might have been okay. I'm just because yeah. Now I understand. Okay. So the 1 coordinate, whereas this mark 1. So this is actually 256. Yeah, I need to add this 256 here as well. So mark 257. And then stack pointer equals 1, 257. Let's see, this should now work on the example as well. Ooh, section BSS will not fit. No. Oh. Let's hope this is enough. Let's hope this is enough. No, still not fit. Wait, what? Okay, let's see with this. Oh. Yeah, getting pretty tight on memory here. Okay, so let's see what the example says. Okay, so yeah, so this is because, oh, now I'm printing a lot of this stuff. Because I got this 256 extra. Oh, okay, perfect. Okay, so now if I run this, example should be 62. Yeah, 62. Okay. Great. Okay, now I can run again and hope that everything pans out. But the thing is that I'm so at the brim of memory usage that if I need to store RGB values per cell in second part, I am going to need to use the RAM expansion unit. Let's hope this doesn't crash. Oh, and I did run out of stack space on my search. Crap. Crap. Well, it's technically still actually filling, so I wonder what's gonna happen. There are these smarter flood fill algorithms that require less of a stack space. Should I try to implement one of those? Yeah, let me try to implement one of those smarter stack flood filling algorithms. So, so the idea is that when I'm filling and how did this go here? Okay, you can be like that. I don't care. Or actually, this would be just like this. Yeah. So the idea here is that I would fill horizontal scan lines without using the stack. So I would go left and right. For U16 x equals, let's do x minus 1 here. Or actually, let's first check if marked XY return. We don't have anything to do here. And we mark XY. So now we do for UA16 x equals, let me do positive direction first, x plus 1, not marked xy plus x. So we mark xy. And then the idea is that so horizontally, so I would be drawing a straight line without using the stack here. But whenever I see like above or below these openings, so I think this is like if not marked xy minus 1. SB plus plus equals x y minus 1. If not marked. And then also to mark x 1 minus 1. And then if same for the positive direction. If not marked y plus 1. And then I have booleans up equal false and down equal false. And then what I do is I look if not marked x y minus 1. So if not up, and or let's do bool u equals oh no marked bool u equals marked. So the idea I'm moving horizontally, so if at the previous pixel actually this should be true. So the previous pixels were marked. If previous pixel above me was marked, but this current one is not, then I need to add the vertical direction as well to the stack. But only add it to the stack where an opening comes up. And then I do the same for below. Pull down equals marked x plus 1. If not down and, or if previous was down, if previous was marked and currently it's not, so there's basically an opening that we need to start filling into. Yeah, we don't need this. But we also need to do this whole same thing. Actually, let me do this. While not marked x minus 1 y minus x. Yeah, so the idea is that let me first wind to the leftmost location on this scan line. Then mark it. But hold on. I was supposed to be marking eagerly. So actually I do expect this to be possible. Oh. Okay, yeah, that's maybe a little bit complex, but okay, I think this should now be a nice scanline based flood fill that doesn't take or shouldn't take as much memory. Let's see. Yeah. Actually, I don't need to now mark this one. I can leave this here. It's okay. I'm on the example. Let's run it on the example and see if that works. 68. I was supposed to get 62. So I'm getting more than before. Oh. That's because marking doesn't check. So I cannot mark, I cannot call marked or mark if that is flagged. Or actually, no. Let's put this in the check in. Yeah, let's put this check in here. Oh. So this is a little bit inefficient, but should be good enough for this purpose. Oh. Okay. So now I shouldn't be getting duplicate counting. 62 should be the answer for the example. 58. Ooh. 58. Oh, come on. Well, I'm not filling 4 squares. Okay, so this one is not filling 4 squares. Why isn't this filling 4 squares? Okay, so I'm filling a point. If it's not marked, I go as far to the left as they are not marked. And I mark it. If the vertical or the 1 pixel above is not marked, mark that one. Actually, don't mark it. And... oh, no, I do want to mark it. Mark X. Y minus 1, because I don't want to get these entries. Oh, but I don't want to do this right away. No, wait, I do. So... oh, should X equal just X? Oh, and this should... I don't need to do any of this manually. Don't need to do any of this. Wow, what am I doing? Okay. So zoom, wind back to the start of that scan line. Here, mark XY. Check is above is not marked. But the last previous scan line was. Mark this one. And add it to the stack. And also for down. Very interesting. Oh, and now I'm not getting almost anything. Oh, it feels like I cannot mark here. I cannot mark here. Maybe. Oh yeah, that was the issue. Okay. That was the issue. But wait, if I don't do this, no, I think it should fine. Okay. So this should be like this. Cool. Okay, but the real question is, does this flood fill actually use less memory? Let's see. Gives a blast to the past from like reading these really old articles about like what is the ultimate flood fill algorithm that uses the least memory. Like those were the old days stuff. And nowadays you just do a stack where you put every single cell onto the stack and don't think too much about it. That's pretty cool. Please don't crash. I only have 1,000 entries in my stack and the height is about half of that. At least it's taking quite a bit of time. Maybe it crashed and it just doesn't print anything. Maybe I should have added a progress dialog. Oh, and I of course had this whole print here. Okay, and now I have a lot of filled stuff. Yeah, that looks good. But now I need to be really careful about not accidentally clicking past the final print. It printed, I think it printed 4490. I could just glimpse it, but I am going to run it again. Just to be sure. And actually, did I? So I have this oops here if I go out of bounds. But here I don't have a guard for going out of bounds here. So let me add that. Okay, and let's save this. Oh, it looks like my Christmas videos have been running without music for quite a while. I don't know what happened there. But all right, cool. Okay. That's gonna be a couple minutes. Oh, okay. No. 4490. Yeah. Cool. Okay, so let's try submitting that. 18 here. Oh, not the puzzle input. No. I didn't want to do that. Answer 4490. Oh, too low. Okay, maybe my flat fill then missed a spot. It probably did. Okay, yeah, I need to take a break. And sadly, I think I'm gonna take this to the PC. I think this will be something that I can I mean, I can just print the whole map and see, and I can do the naive flat fill there. Yeah, but I will for sure port it back to the C64 when I'm finished with the code. So, but yeah, I've been online quite long, so it's been 2 hours now. So I'm gonna take a break. And then maybe I'll need to carry per cell state for the RGB values in the part 2. So that will be something that then comes to bite. We'll see. We'll see what happens with that. But in any case, that's everything that I have for now. So take care, internet, and I will see you tomorrow. Bye.